All right, Unit 4, Lesson 8. Okay, so for skills maintenance today, page 175, go ahead, pause the video, work on that page. All right, so for skills maintenance today, it's all about transferring between fractions, decimal numbers, and percents. Okay, now when you look at this like 3/4, that's the same as 0.75 and the same as 75%. Okay, so remember, if we go from a decimal number to a percent, you are just moving that decimal place 2 places to the right. Okay, now it'll give you the percent. All right, now 25%, if we go to a decimal, it's just the opposite. Percent to a decimal, moving that decimal place 2 places to the left, so that 0.25. And then 25%, okay, you can think of it as 25 over 100, but will eventually simplify to 1/4. It's going to be easier to use that 1/4. These are ones that you should really have memorized. Okay, 5/5, okay, 5 over 5, that is just 1. Anytime that numerator is the same as the denominator, it is 1, and 1 is 100% as a percent. 1/5, okay, that is 0.20. That's another common one we should just know. Changing that to a percent again, moving that decimal place to the right 2 places will give you 20%. Okay, 50% or 0.5, 50% is half. That's a common one we should just know. 4/5 or 80% now. Okay, taking that decimal, moving it to the left 2 places, we get 0.8 or 0.80 if you want to. Again, you don't have to have that 0 there. Okay, so for the fraction of 1.5 or 150%, there's a couple of ways you can write this. Okay, you got 1.5 is what it's really saying, 1.5. You got 1 whole, 0.5 is half, so 1.5. So if you write that as a mixed number, it's 1 and 1/2. Okay, or you can write it as an improper fraction of 3/2. Again, multiplying the denominator by the whole, 2 times 1, plus the numerator, that gets 3, and the denominator stays the same. All right, so decimal number now, when we get 33.3 repeating percent, okay, still just moving that decimal place to the left twice, that's 0.3 repeating. All right, so many of those, probably other than the 1.5, 150%, and then the 3/2, those ones are common ones that we use, and you probably should have memorized. It will make things a lot easier. All right, so today, describing even, odd, and prime numbers with algebraic expressions. Okay, so even numbers, that's the 2, 4, 6, 8. We can go on forever and ever with that. You're just really counting by 2's. Odd numbers then are those ones in between. 1, 3, 5, 7, 9, 11, 13. Again, I can go on forever and ever with that. Now, let's use the algebraic expressions to represent those. Okay, now an even number is any number that can be divided by 2 with no remainder. Okay, we've discussed this through class, through most of the year. Okay, anytime you have an even number, you can divide by 2, and that is really actually the definition of an even number. Okay, now, so let's say we got 8. Okay, if we divide it into 2, okay, you got 2 groups of 4. Okay, with no remainder. Now, so that's an even number. Now, if we had an odd number of coins, it's 9. We divide that into 2. We cannot split it into 2 even groups. Okay, you get that remainder of 1. Okay, so that is an odd number. Now, an even number is any number that can be divided by 2 with no remainder. So we're going to let k be any integer. Okay, integer meaning those numbers we can count by, including the negatives. Okay, so if we said we can divide it by 2, okay, any even number we can represent with 2 times k, where k is representing an integer. Now, no matter what k is, 2 times any number, it will be an even value, because that is the definition of an even number. Okay, which is just k plus k. Okay, so an even number can be represented with 2 times k, where k is any integer. Now, for those odd numbers, it's a little bit different, because we're going to have that remainder. Okay, an even number does not have a remainder when divided by 2. An odd number does have a remainder when we divide by 2. Okay, so you're going to use that 2 times k. That gets you that even number. And then if you just add 1 to that value, that's going to get you to that value in between that even number and the following one. Okay, so that's going to get you 2 times k plus 1. Okay, so 2 times k plus 1 there. That is how we represent odd numbers using algebraic expressions. Okay, we can describe any odd number as 2 times k plus 1, where k is any integer. Now, prime numbers. Okay, a prime number is a number that is divisible by only 1 and by itself. Okay, so it only has 2 divisors. Okay, or I should say factors. 2 factors. So 2 times k is for even numbers, odd numbers 2 times k plus 1, and then prime numbers z, where 1 and z are the only divisors. Okay, so again, z is representing that number. Alright, so using variables to talk about different types of numbers helps us see their basic patterns. So apply skills, page 176. Go ahead, pause the video, and work on that page. Alright, so for apply skills today, write each number as 2 times n or 2 times n plus 1. Okay, so what we're going to go through, I'm going to write the even numbers in blue, the green, and then the odd numbers in green. Okay, to represent 10, the way we would get that, we could say 2 times 5, where 5 is that integer, and that equals 10. That's an even number. Okay, for 11, you would have to do 2 times 5 plus 1. That will give you 11. Okay, so again, blue or odd or even, green or odd. So then for 12, that would be 2 times 6. Odd. For 13, 2 times 6 plus 1. That gives you 13. For 14, that would be 2 times 7. Then for 15, that would be 2 times 7 plus 1. Okay, and I could keep going on and on with that. I think you see the pattern of where it's going. Okay, the next one we do 2 times 8. 2 times 8 plus 1. 2 times 9. 2 times 9 plus 1. Alright, so which numbers work for 2 times n? And again, 2 times n, that's representing those even numbers. Okay, so all we're doing here is going through with our even numbers. 10's an even number. 12, 14, 16, 18, 20, 22. Okay, and what you're going to notice, an even number always ends with a 0, 2, 4, 6, or 8. Okay, those are our even numbers. Now for odd numbers, okay, that's just those values in between. So 11, 13, 15, 17, 19, 21. So what you're going to notice with odd numbers, they're always going to end with a 1, 3, 5, 7, or 9. Okay, so when it comes down to figuring out if something is even or odd, all you're really looking for is that very far right digit in whatever number you're doing, and the digit that's in the ones place. And if it's a 1, 3, 5, 7, or 9, it is an odd number. Okay, now, which numbers work for n divided by n equals 1, and n divided by 1 equals n, but are not divisible by any number, any other number? Okay, so what this is saying is it's divisible by itself and divisible by 1. Okay, these are our prime numbers. Okay, so 10, now, if you think about it, even numbers are always divisible by 2. So we can right away eliminate our even numbers. There's no way those are prime. Now, when we do this, okay, 11, there's no other factors of 11. So 11 is a prime number. 13 is a prime number. 15, okay, 15 is divisible by 5. Okay, so that is not a prime number. Okay, so again, a prime number is divisible by 1 and itself. 17, there's no other number other than 1 and 17 that go in there. 19 is also. Then when we get to 21, okay, 121, and then I can also multiply 3 times 7. So that's saying 21 is divisible by 3 and 7, meaning it is not a prime number. Okay, so again, these are my prime numbers. And we can keep going on with that and find other prime numbers, but that's all we're given. All right, so that was apply skills. Now, for problem solving. Okay, we'll solve problems involving percent increase. So if we go to our problem solving activity, okay, solve the following percent increase problems. Be sure to use the totals, whole, or 100% and the change for the proportions. So the first one, last year the Indiana Hawks won 16 games. This year they won 20 games. What is the percent increase in their winning games over last year? So now remember, whenever we are doing this, it's always the change over the original is equal to x over 100, where x is representing the percent. Okay, now in this case, number 1, okay, they went from 16 games to 20 games. So the difference, okay, again, difference is subtracting 20 minus 16. That gives us a change of 4. They won 4 more games than they did the previous year. So 4, and they originally won 16. Okay, and again, we always set that to equal x over 100. And now to solve that proportion, I'm going to go ahead and use vertical in this case. To get from 16 to 4, we're going to divide by 4, which will give us 100 divided by 4, which is 25. So there was a 25% increase in the amount of wins that the Indiana Hawks had for that year. All right, so number 2, prices are going up for gold necklaces. That's because the price of gold has gone up over the last year. A 24-karat gold ring last year cost $600. This year it costs $750. So again, we need to find the difference or that change. And the way you do that, larger number minus the smaller number. So there was a change of $150. Okay, you were paying $150 more for that necklace this next year. So our change was $150. The original price from the previous year was $600. And again, set that equal to x over 100. Okay. So then from there, I would go horizontal to get from 600 to 100. You're going to divide by 6. Okay. 150 divided by 6 is 25. Okay, because I know 25 times 6 is 150. So there was a 25% increase on the price of gold from the one year to the next. All right, the next one, the average temperature in May is 90 degrees Fahrenheit. In June, the average temperature rises to 99. Okay, so again, we need to find that difference, which is 9 degrees. Okay, what is the percent increase in the average temperature from May to June? So the change was 90. The average in May was 90. Set that equal to x over 100 again. Okay, and I'd go this route this time, vertical. 90 divided by 10 is 9. Okay, so 100 divided by 10, we get a total of 10, which is a 10% increase. All right, so last one. There has been very little rain in California where crops are growing. Farmers are paying more for water, and their costs are passed on to grocery stores. The table shows changes in the last month for food prices. Okay, which fruit, grape or oranges, had a greater percent increase from 2014 to 2015? So since it was grapes and oranges, that's the only thing we're going to worry about. Okay, grapes are here, oranges here. So the first thing we need to do is we need to figure out the difference between 2014 to 2015. Okay, it was $20 in 2015, $16, which is a change of $4. Okay, for the oranges, it was $8 in 2015 and it was $5 in 2014. So the difference there is $3. Okay, so let's go ahead. Let's do oranges first. Okay, so again, the change was $3 and it started out at $5. And we set that equal to x over 100. Okay, from there, I would go horizontal. 5 times 20 is 100. So 3 times 20, we get 60. So there was a 60% increase for oranges between those 2 years. Now, for grapes, okay, again, we had that difference of 4. The change was $4, and it was originally $16. Okay, again, set it equal to that percent, or x over 100. Again, I would use vertical here. 16 to 4, we're going to divide by 4. We get x is equal to 25. So that's a 25% increase. So which fruit, grapes or oranges, had a greater percent increase from 2014 to 2015? Oranges, since it had 60% compared to the 25% of grapes. All right, that was lesson 8. So make sure you go into your homework, complete lesson 8. If you have questions, make sure you ask. Otherwise, have a good day.